Hey there! Today what we're going to be looking at are reduction potential tables, how we use them, why they're helpful, why they are our friends in the study of electrochemistry. So what we have here is a standard reduction potential table. Okay, so what you see is a bunch of reactions, and every reaction there is actually a reduction reaction. So F2 is gaining 2 electrons, or copper 2 plus is gaining a single electron, or iron is gaining 2 electrons. These are all gaining electrons, that's their reduction. This is set to where the reduction of the hydrogen ion at a 1 molar concentration has a voltage of 0. So that's our tabletop. Everything is relative to the reduction of hydrogen. Everything above that has a higher potential for reduction. Everything below that has a lower potential for reduction. So all of these reactions are reduction. Lithium, lowest potential for reduction. I'm sorry, the lithium ion, lowest potential for reduction. Now, you may ask yourself, why don't we have a table of oxidations then? Because you can't have one without the other. There are oxidation reactions as well. We just simply have to read it backwards, like Hebrew. So we're going to read right to left. So 2 bromides become bromine and release 2 electrons, but do so at a negative 1.07 volts. Or I can I can oxidize copper into copper 2 plus at a voltage of negative 0.34 volts. So we read it backwards, change the signs, we have our oxidation potentials. So everything over here is undergoing a reduction. Therefore, these are oxidizing agents. Everything on the left is an oxidizing agent. Obviously, what we see is the strongest oxidizing agent here is fluorine. He is our strongest oxidizing agent. Why? He has the highest potential for reduction. As we go down to the bottom, lithium is undergoing reduction. It's an oxidizing agent, but a very weak one. It does not like to undergo oxidation. Its voltage is very negative. It has a very low potential for that. If we look at the other side, then what we're going to see is these species are undergoing an oxidation. Therefore, they're reducing agents. But when we're talking about that direction, we change the signs. Therefore, the fluoride ion undergoing oxidation has the lowest potential for that. It is the weakest of the reducing agents. Does that make sense? It's undergoing oxidation, so it's a reducing agent, but it's doing so at negative 2.87 volts. If I scroll down to the bottom here, in this particular table, lithium undergoing oxidation is at positive 0.305 volts, making it the strongest reducing agent on this particular table. So these guys over here undergoing oxidation, they're our reducing agents. These guys over here undergoing reduction are our oxidizing agents. And we just look at the values of the voltage to determine strength relative to one another. So I've pared down the table a little bit here, so we're only looking at assorted reduction potentials just for the sake of the argument. And again, to beat the dead horse, these are undergoing reduction, they're oxidizing agents. Reading it backwards, they'd be undergoing oxidation, therefore they're reducing agents. All right, which species has the highest reduction potential on this list? So these are reduction reactions. So the one with the highest potential, obviously our choices are on the left here. The highest potential would be that of the Cl2, the chlorine. It's got the highest potential for reduction. All right, which species here is the strongest oxidizing agent? So oxidizing agents are undergoing reduction, so our choices are on the left side, and the strongest would be chlorine, right? Because it has the highest voltage for reduction. All right, which species has the lowest potential for oxidation? So oxidation would be reading right to left. So this is my choice. The lowest potential would actually be chloride, Cl2, right? As its potential for oxidation is negative 1.36, which makes it the lowest in the group. Next question, which species is the second weakest oxidizing agent? Oxidizing agents undergo reduction, so my choice is over on this left side. The second weakest would have the second lowest voltage, so I'm guessing the potassium ion would have this, is the second weakest of the oxidizing agents in this list. Okay, which species here is least easily oxidized? So it would have the lowest potential for oxidation. Oxidation is right to left. I'm flipping the signs in my head. It looks like chloride ions are the ones that have the least potential for oxidation, therefore they're least easily oxidized. All right, which of these species is the second strongest oxidizing agent? So oxidizing agents are undergoing reduction, so my choices are on the left. The second strongest would have the second highest voltage, so the copper 2+ ion would be the second strongest oxidizing agent in this list. So can chromium reduce calcium? So the first thing I want to do is find those two guys on this table. So calcium 2+ is right here, and chromium is right here. So we want to look at the two voltages of those two different things. What I have is the reduction of calcium is negative 2.76 volts. And I'm going to add that to the voltage for the oxidation of chromium, which is positive 0.74 volts. And so what I get here is a negative 2.02 volts for this particular reaction. Is it spontaneous? Well, it's got a negative potential. If you have a negative potential, that's not good, right? That's not going to happen on its own. It is a non-spontaneous reaction. Chromium cannot reduce calcium. All right. Can a chromium 3 ion oxidize calcium? And again, I'm just going to find those two things in the table. So the chromium 3+ is here. The calcium is here, and I'm simply going to add the two voltages together. So the voltage for the calcium oxidizing is positive 2.76. The reduction of the chromium 3 is negative 0.74. So what we see here is the total voltage for this reaction is a positive 3.50 volt, a positive potential. So that means chromium ions can oxidize calcium. All right, we'll work on this one in our heads. Will sodium react with potassium? So our sodium ion is, our potassium is here. The voltage for the oxidation of potassium is positive 2.92. The reduction of sodium ions is negative 2.71. Add the two together and what do you get? You have a positive potential. Therefore, potassium ions will react with sodium. It is a spontaneous reaction. All right, so what we've learned is the reduction potential sheet actually allows us to figure out oxidation potentials as well. We understand that one side, the left, undergoing reduction is the oxidizing agents. On the right, reading right to left, things undergoing oxidation are reducing agents. And we use the two voltages together as a sum to figure out whether or not reactions are spontaneous or non-spontaneous. Will they happen or not? All right, thank you.